eigenvectors, we got these values, 3 eigenvalues. When we solve them to find the eigenvectors, we have 3 eigenvectors. We put them, we got P. So if P inverse AP, it will give me the D, which is the diagonalizable matrix. Here in this way, you have eigenvalue 1, 2, 3, everywhere else is 0, everything else. And one more issue to be mentioned here, when we have a upper triangle, lower triangle, triangular matrix, okay, it's apply the diagonalizability because directly we have here the eigenvalues. So we know that this is diagonalizable matrix. Now here are more exercises. I advise you to work on them to find the eigenvalue, then eigenvector, then diagonalizable matrix P. Now next I will use what we discussed until now to solve set of differential equations. And just to let you to remind, what is this differential equation? When we have dy over dx, we study this in level 1, which is sometimes we call it y dash or f of x dash. It means first derivative of y. When we solve it to find y, okay, the original matrix. It has been differentiated, we integrate to get back to the original y. Now he told me here you have set of equations. My variable here is not y, we call it x1 dash, x2 dash, in terms of constant x1, x2, x3 and so on. Set of equations. And we have constants, okay, sorry, initial condition, which we use it to find the constants. As example, x1 at 0 time equals c1, as x2 is 0 time equals c2 and so on. First of all, I write it in matrix form. I construct A, the x elements. I construct X matrix, which is x1, 2, 3 and so on. I construct the X dash matrix, which is x1 dash, x2 dash and so on. I can write it in this way. What I want to do to solve this is to find X. Okay, find, the original matrix, because it's X dash, I integrate to find X. Definitely, working according to the methods known, it will be boring, tedious, okay? But using using eigenvalue, eigenvector and diagonalizability, we just discussed in the previous examples, we can solve it easily. How? Have a look. Let's assume this X is represented by QY, where Q is invertible matrix, the diagonalizable one I just mentioned. Then we can say X dash, okay, here equal QY dash, right? Now if I take this and put it here, X dash here, okay, I have QY dash equal A X, here you see here X, which is QY, as you can see. Now multiply by Q inverse, so this one will cancel and the Q inverse coming here, as you can see. This part together represent, okay, represented D, where D is the diagonalizable matrix contained, it's going to contain the eigenvalues. Now this make the solution is easily and we find X. Now let's apply this idea in this example. He gave me two equations, 1 and 2. This is x1 dash equal x1 plus 3x2 and y2x2 dash equal 2x1 2x2. And also he told me that x and y are function of time, and x1 at time 0 equals 0, x2 at time 0 equal 5. Now let's write first the matrix form for the two equations. This is a 1, as you can see here, 1 3 2 2, and for x x1 x2, and for x dash x1 dash x2 dash, and for the constant, as you can see here, 0 0, x of 0 equal constant, which is 5. Okay, now this is the set of system equation with the condition. We wrote it in matrix form. Next I will solve A to find the eigenvectors, values then vectors. I got the eigenvector 1 q1 q2 for these eigenvalues 4 and minus 1. Now I will construct them. This is the first column, the second column to represent Q, where Q dash times A times Q will give me D, which is the diagonal matrix, which contain 4 and minus 1, the eigenvalues, as explained before. Now let's consider y1 is y1 of time or of t, and y2 is y2 of t. Then we define in the previous slide x to be qy. Okay, let's write it. X, which represents x1, x2, and this is q we just constructed, times y. So x1 equal 1 times y1 plus 3 times y2. I put here the first equation, I did the same thing, I got the second equation. Okay, I have x equation. Now we have, as I mentioned, y dash equal q dash a qy, which is dy. Okay, now d, we have it, d is this one, okay, times y1 y2, and this is y1 dash y2 dash. If I multiply, it will be 4 y1, and here minus 1 by 2 minus 2 1. So I got two equations for them. By the way, don't forget, this is dy over dx. It means like it's equal to 4y1. Okay, rearrange to separate dy over y1 equal 4 dx. Now if we integrate both, this one will give me ln y1 equal 4x. Okay, or here it is, yeah, it's t, or it's t, supposed to be t. Okay, t dy over dt. Okay, because it's function of t. Now when I take exponential on both, it will be y1 equal exponential 40, as you can see here. And the same thing for the second one, exponential minus t. Now let's put them in the form. This is x, this is q, and this is y1, which is already, we got them here. As you can see, this is the first part, the second part. Now 1 by this value plus 3 by this value, we got this formula. This is the answer. x1 is this formula, and x2 is this formula. You see? Now you may say, okay, can I find x1 and x2? Yeah, we can, because he gave you already initial condition. He told you x1 at time 0 is 0, x2 at time 0 is 5. So substitute here by 0, here by 5, and here for t by 0, 0, and simplify, we got this formula. These two equations, we can solve them simultaneously to find C1 and C2. I will stop here.